For the longest time, we really thought we had the universe pretty much figured out. The pieces all seemed to fit, the math worked, the story from the Big Bang right up to us felt complete. But what if the universe has been hiding a secret? What if, scattered all across the cosmos, there were signals, impossible signals, just waiting to be found? Well, in this explainer, we're going to dive into exactly that, the secret cosmic signals that are completely rewriting everything we know.
And then, 2025 happened. A whole cascade of discoveries, from the frozen ice of Antarctica to the absolute deepest reaches of space, sent a massive shockwave through the entire scientific community. See, these signals weren't just filling in a few gaps in our knowledge. Oh no, they were suggesting that the entire cosmic rulebook, the one we thought we understood so well, was fundamentally wrong.
Okay, so before we get into all that chaos, let's take a second to appreciate the calm before the storm. For decades, our understanding of the cosmos was built on this incredibly successful foundation. I'm talking about a model so powerful it could explain almost everything we could see, from the afterglow of the Big Bang to the massive spiderweb of galaxy clusters. It's called the Lambda-CDM model.
Basically, this model says that everything, and I mean everything, is made of just three main ingredients. You've got lambda, which is dark energy, the stuff that's pushing the universe apart. Then there's cold dark matter, or CDM, which is like this invisible scaffolding that holds entire galaxies together. And then there's us, and everything we can see, which is ordinary matter. And that makes up a tiny, measly 5% of the whole show. This model was the bedrock of cosmology, a beautiful, triumphant theory. Until, of course, the first crack started to show.
And you know what's crazy? That crack didn't come from some massive telescope peering into deep space. Nope. It came from a balloon, a high-altitude balloon floating over the most isolated place on the planet, Antarctica. A clue from deep beneath the ice that would kick off this whole cosmic mystery.
So the ANITA experiment, its whole job is to just fly way up high over the Antarctic ice, listening for these super faint radio whispers. These whispers happen when high-energy particles from space, called neutrinos, smack into our atmosphere. You can think of neutrinos as these little ghosts of the subatomic world, and ANITA is there to catch their echoes. But in June 2025, it didn't catch an echo. It caught something else entirely.
See, ANITA was built to hear things coming down from space. That's the whole point. But instead, it picked up multiple signals shooting up out of the Earth at this crazy steep 30-degree angle. And no, these weren't just some weird reflections. It looked like a particle had literally blasted its way straight through thousands of kilometers of rock and metal, right through the planet, before popping out of the ice.
So how impossible are we talking here? Well, the odds of a high-energy neutrino making it through that much of the planet, it's something like 1 in 10 billion. The Earth should have been a brick wall. It should have stopped it, no question. According to the standard model, our rulebook for physics, this is just not supposed to happen. But it did.
And here's the real kicker. The scientists, they immediately checked with these other, even more sensitive detectors that are actually buried deep in the ice, like the Ice Cube Observatory. And what did they see? Zilch. Nothing. No other signal. So this wasn't just some instrument glitch. It was a real, confirmed event. And it hinted that some kind of particle, something completely new to physics, was zipping right through our planet.
All right, so while the physicists are scratching their heads about this impossible particle on Earth, a whole other mystery is popping up at the very edge of space and time. This time, it's astronomers using the James Webb Space Telescope, and they're finding impossible galaxies. And this is a big deal, because it doesn't just challenge our understanding of a particle, it challenges the entire story of how the universe was born. I love this quote from Hao Jingyan. It just perfectly sums up the shock. They were finding these things way back in the early universe that mashed together features that, today, you never see them in the same object. They were so weird, so contradictory, they actually got nicknamed platypus galaxies.
So why a platypus? Well, think about it. These things looked like these tiny, super bright pinpricks of light, right? Just like a quasar, which is a monster black hole just gobbling up everything around it. But when they looked at the light itself, at these things called emission lines, which are kind of like a chemical fingerprint, the lines were narrow. Quasars always have broad lines because all that gas is swirling into them at insane speeds. So what they were seeing was something as bright as a feeding black hole, but as calm and quiet as a sleepy little dwarf galaxy. It just made no sense at all.
And the real head-scratcher was when these things were showing up. We're talking just over 1 billion years after the Big Bang. Our models are really clear on this. Back then, the universe should have been messy, just forming these little clumpy proto-galaxies. Finding something this big and bright this early, It's like stumbling across a fully built skyscraper in a Stone Age village. It just shouldn't be there.
Okay, so we've got an impossible particle and an impossible galaxy. The third signal, this one wasn't about the past, it was about the future. It threw a huge question mark over the fundamental force that's driving the expansion of the entire universe. And that means our whole understanding of how this story ends, well, it was suddenly up for grabs.
For years, we've had this idea that dark energy, that's the lambda in our standard model, was a constant. Just this steady, unchanging force pushing everything apart. But then, in March 2025, the DESI survey, after mapping out millions of galaxies, came back with a bombshell. That's just not true. Dark energy isn't constant. It's actually getting weaker.
And when you look at the timeline, you see this really dynamic history. Billions of years ago, dark energy was actually stronger than it is now, a phase scientists call a phantom phase. Then, about 4.5 billion years ago, it started to weaken. It's like the engine that's driving cosmic expansion is slowly throttling down.
And this changes everything. The old idea with a constant dark energy was that the universe would end in a big rip, literally everything getting torn apart. But if dark energy is fading, the big rip is off the table. Suddenly, the future is a complete unknown. Will it just coast into darkness? Could it collapse back in on itself in a big crunch? We have no idea. Our cosmic destiny is a total mystery all over again.
So, you've got impossible particles, impossible galaxies, and a future that's completely changed. It's pretty clear the old rulebook just isn't working anymore. So, what do? How are scientists trying to explain all this? Well, this is where things get really interesting, and the hunt for new, sometimes pretty wild answers really begins.
Okay, let's go back to those platypus galaxies. What if they aren't galaxies at all? There's a new theory floating around that they could be something we've never seen before, a supermassive dark star. Imagine a colossal star, but one that isn't powered by nuclear fusion like our sun. Instead, it's powered by dark matter annihilating itself. And the way it would work is actually pretty elegant. Back in the super dense early universe, you'd have these huge clouds of dark matter. They'd clump together, the particles would annihilate each other, and release a ton of energy. This would create this giant, puffy, super bright object. It would look like a pinpoint of light, but without all the violent, swirling gas you see in a quasar. It perfectly explains the platypus features. And, get this, it even solves another mystery. Once it runs out of dark matter fuel, it collapses and creates the perfect seed for a supermassive black hole. Now, another huge clue didn't come from something we found, but from something we didn't find. Astronomers discovered this thing called Cloud 9. It's this massive cloud of gas and dark matter from the early universe. It had all the right ingredients to become a galaxy, but it just never did. It's a failed galaxy. Think of it like an abandoned house in the cosmos. It's this perfectly preserved fossil from the time when galaxies were first forming. And by studying why this one failed to light up with stars, we can actually learn more about what it takes to start a galaxy than we could from studying 1,000 successful ones. It's the perfect laboratory for testing our new ideas.
So, when you step back and look at all of this together, the impossible signal from Antarctica, those bizarre galaxies from the dawn of time, the fact that the future of the universe is changing, the message is unavoidable. We haven't just found a few missing puzzle pieces. We've realized we've been playing the wrong game the whole time. Our model of the universe, it isn't just incomplete, it's broken.
So let's just recap the three big signals that are rewriting all the rules. First, you have an impossible particle that just shouldn't exist according to the standard model. Second, massive, bright galaxies showing up way, way too early in the universe's life. And third, the fundamental force driving the whole cosmos is changing on us. Any one of these would be a massive revolution in science, but all three together, that's a whole new paradigm.
That neat, tidy little picture of the universe we had, it's gone. And in its place is something way more complex, more dynamic, and honestly, a lot more mysterious. We are literally standing at a new frontier of physics, watching the rules get rewritten in real time, with every new discovery. And really, that just leaves us with the most exciting question there is. What impossible thing are we going to find next?